Well, hello, all my babies out there. Hopefully, you're having a good time. We're going to be talking about the surface area of 3D figures. This is going to require you to picture things and visualize things in 3D. I do have some shapes in the room that you can go take a look at if you need to, but we need to know some vocabulary first. First, a face, that is just any 2D side, I guess. Any 2D side or flat surface. So like looking at the triangular prism here, there's 2 triangles and 3 rectangles. All of those are 2D flat surfaces. So like this figure here has 5 faces. 5 faces on that shape. Whereas like this guy, 1, 2, 3, 4, 5, 6, 7, 8, has 8 rectangles and 2 octagons. 8 rectangles and 2 octagons. This guy has 10 faces. So you need to know what a face is. Next, we have the bases. Well, the bases are, there's a few things that make it a base. It must be, they are congruent and parallel. Also, they're also, like if it is a prism, they're going to not be the rectangle. If it is a pyramid, they're going to not be the triangle, unless you have rare cases where it's a rectangular prism. So on this one, you could actually pick the base. You could make the front the base. If the front's the base, then the height would go forwards to backwards. You could choose to make the bottom the base. If you choose the bottom to be the base, now your height is up and down. You could choose any face to be the base on this shape. But over here, it's not the rectangles. Your base must be the triangles. They are the only 2 shapes that are parallel and congruent. Over here, yes, these 2 rectangles would be parallel and congruent, but those are not the bases because another way to think about it is the shape that's not the rectangle. So here the octagons have to be the bases. They're parallel and congruent. There you go. Lateral faces. Lateral faces connect the bases. They are the faces that are not bases. For a prism, they are parallelograms, usually rectangles. Usually rectangles. And for a pyramid, they are triangles. So looking at this shape, we have 1, 2, 3 rectangles. This shape has 3 lateral faces. Over here, this shape has 8 rectangles. That is 8 lateral faces. So we need to know what those words mean. So faces are just any of the flat surfaces. Bases are the parallel congruent surfaces that are not rectangles, that are not that are not rectangles or parallelograms. It's the unique shape. Unless they're all the same shape like this middle one, then you get to pick. The lateral faces are the faces that are not bases. They're the sides that connect the bases. So like on this shape, the rectangles connect the 2 triangles. Here, the rectangles connect the 2 octagons. It's the faces that connect the bases. Those are the lateral faces. So they're not the bases. Capital P is the perimeter of the base. Capital B is the base area. And this is the height of the prism / pyramid. Okay, so that's some words you need to know. We're going to move on. We're going to talk more about the formulas now. We're going to talk about nets. Like, can you picture this shape folding into this one? It's not something I'm really going to teach you on the video here, but I'm going to give you a second. It'd be awesome if you went ahead and paused the video and ask yourself which one of these would fold into a cube. All right, so hopefully you took a second to figure out which ones make cubes. There's only 2 that don't make a cube. These 2 shapes would not form a cube. All the rest of them would fold into a cube. You can put it in paper and try to figure it out. I'm not going to do that in the video, but all the rest of them would fold into a cube. All right, so let's talk about how you can derive the surface area formula. So for this net, remember that would fold into this triangular prism. We're going to come up with the formulas for this prism. Now, you could just individually get the area of every surface and add them together, but we're going to talk about how to simplify that process and do them all at once. So I want you to think real hard. If you were folding this shape, where would that black line land? Well, when you fold it up, it would be this side of the triangle. How about this blue line? Where would it land? It would be this side of the triangle. And then this pink area, well, it would be itself. So what is that distance? When you lay out all three of those colors, black, pink, and blue, wouldn't they wrap around the triangle? Wouldn't those be the perimeter? So this lateral section, so these rectangles, this is the lateral, right? Boop, that's the lateral. These are the two bases. This lateral section, wouldn't this entire side represent the perimeter of the base? And when you fold it up, wouldn't this be the height? Wouldn't this distance be the distance that connects the two bases? So if I want to get the area of all of those combined, we call it the lateral area. We would do the perimeter of the base times the height. It's one big rectangle. So that's where this comes from. That is the perimeter of the base times the height. Now, what if you wanted the total surface area? And that's what we usually write S. S means surface area, implying the total surface area. To get the total surface area, you're going to do the lateral again, right? That's the lateral, plus the two bases. So I need to add on those two triangles. So we're going to be getting the area of a lot of different shapes. Those bases could be anything. Those bases could be pentagons, octagons, triangles, you name it. The bases could be anything. And then I threw in the cylinder formula here. If you were to roll out a cylinder, the net of a cylinder would look something like this. And it's the same idea. Wouldn't this green distance wrap around the circle? Well, that is the circumference of the circle times the height. That is circumference times height. So that's where the formula comes from. And then what is this? Well, the area of a square is the area of a circle is pi r squared. So you need to add in 2 pi r squareds to get the total. So again, this is actually really just ph plus 2b. It's just that p is 2 pi r, that's the circumference of a circle, times h, well, that's the height of that rectangle, plus pi r squared, that's the area of one circle, times 2, because there's two circles. So really the cylinder and the prism follow the exact same formula. And a lot of times they write prism slash cylinder, and they just give you those two, and they expect you to know how to do it specifically for the circle. All right, so let's do a problem here. It says a prism has a base that is an equilateral triangle. These are tough for me to draw. I'm not good at drawing them, but I'll do my best. So we have a prism that is an equilateral triangle on the base. If the perimeter of the triangle is 18, so really often what I'm going to do is I'm going to draw the base separately. If the perimeter is 18, that means each side is 6. And the height of the prism, this is really important. It says height of the prism. Is that this number? Is that the height of the prism? No. This, the line that connects the two bases, is the height of the prism. All three of those would be the height of the prism. And they're telling us that is 10. Find the surface area. So we're working on a triangular prism. The surface area is ph plus 2b, where p is the perimeter of the base, h is this height, the height of the prism, and b is the area of the base. Well, there's only one number that we currently know. We know the height of the prism is 10. We need to find the perimeter of the base and the area of the base. Those both involve just this. That's what we worked on last week. That is what we worked on in the last video, is getting the area of these flat shapes. So we do know the perimeter, my bad. The perimeter is 18, they gave us that. So the perimeter of that shape is 18, but we need the area. So because it's an equilateral triangle, this corner would be 60. This would be 30, 6 divided by 2, this would be 3. And the height would be 3 root 3. So the area, I'm going to call it capital A, well, really it's capital B on these. Sorry about that. It's the area of the base. The area of the base is 1/2 base times height. So the area of the base is 1/2 times 6 times 3√3. 6 is the base of the entire thing, and 3√3 is the height. I know this gets really confusing. This B is the base of the triangle. This B is the base of the prism. This H is the height of the triangle. This H is the height of the prism. It's going to be tough to keep it straight. That's actually going to be the hardest thing for most people, is to know which B are we talking about? Which H are we talking about? Where does it go? What do I do with it? You have to keep it organized and know what you're working on and what it represents. So the area of the base would be 1/2 of 6 is 3 times 3 is 9√3. So capital B is 9√3. Once you know the parts, you're just plugging it in. So the surface area is the perimeter of the base times the height plus 2 times the area of the base. So that would be 180 plus 18√3, and we're done. If they ask you to round, you type that in. So we just got the surface area. Quick note, if they said find the lateral surface area, the lateral surface area would just be that 180. That's the lateral surface area. But they didn't say that. They said find surface area, which implies total surface area. All right. So that's a prism problem. Let's talk about a pyramid question. So some more words that you need to know, and pyramids are way tougher for most students. So remember, what does surface area even mean? So I need to be very clear. Surface area is not volume. We're going to do volume later. Volume is how much space something takes up. Surface area is the area of every individual surface added up. In this case, it's rectangle plus rectangle plus rectangle plus triangle plus triangle. On the cylinder, it is circle plus rectangle. It's if you laid it flat and add up the area of every surface. You can have a ton of surface area and have very little volume. Like a piece of paper is very thin, but it has 2 long sides. A piece of paper has a lot of surface area, not a lot of volume. So please don't confuse those. We have to work on the surface of this shape. If I were to unfold this, what are the shapes we would have? We would have a square, or a rectangle at least, and we would have 1, 2, 3, 4 triangles. And each triangle has its own area. So what are some words? Let's talk about what these words mean. The lateral edge is from the apex to the corner. It's on the outside of the shape. This is called LE. I'm going to call it LE for lateral edge. You need to know what that is. Base edge. Base edge is one of the sides of the base of the shape. So this is my base edge. All right, so we know what a lateral edge is. We know what a base edge is. Let's put them up here. Like all 4 of these would be base edges on that square/rectangle. The bottom of each triangle would be a base edge. All of those, right? Like if I were to draw this triangle, the bottom of it is the base edge. Now the other parts, all of the sides, are lateral edges. Lateral edges. Those are lateral edges. And then we have something called a slant height. This is probably something you haven't messed with very much, but a slant height starts at the apex and slants to the midpoint of the bottom, and it's perpendicular. It's a height. That would be this line. It's called a slant height because it is a type of height. It's the height of the triangular face. Is it the height of the pyramid? No. The height of the pyramid, which I'm running out of colors, the height of the pyramid would be from the apex to the bottom, and that can't be represented on any of those. These are surfaces. The actual height of the pyramid is inside the shape. It can't be represented. So understanding these will be critical to your success. I'm going to show you an actual picture here. So let's take a look. So I got this thing. This thing has all of those pieces that we're talking about. So this is my 3D printed pyramid. It's in the classroom. You can take a look at it if you want to. Ask the sub or the teacher if I'm not here. But from the apex down to the corner, this is the lateral edge right here. This line that goes down the middle of the triangle is the slant height. Notice that for the pyramid, it is slanted. But if you were to lay it flat, this line would be the height of the triangle, which in order to get the area of the triangle, you need the height of the triangle. On the inside, we can see the height of the pyramid. Notice it goes from the apex straight down. That's the height of the pyramid. So that's really important that you can understand those differences. And then we're going to talk about this here in a minute, but on the actual base, this is the triangle that we've worked with already. This is the triangle that we use for regular polygons. Now, for a square, it's a real simple situation. But if the base is something like this, what is that, 1, 2, 3, that's an octagon? Well, you're going to need to be able to use the apothem and the radius. So like the apothem and the radius, you're going to have to get the area of these bases. So you might have to get the area of the octagon. You need to understand that this right triangle is on the base. That's the one we worked on last week. We're going to have some new right triangles. I'm going to see if you can picture these. But you have 3 more right triangles to consider. The first one has the slant height and the base edge and the lateral edge. Do you see this right triangle? You're going to have to use it to solve for things. The second right triangle is on the inside of the shape. You see the height goes straight down, and the slant height would be the hypotenuse. There's a triangle on the inside, and what is it connected by? What connects the height to the slant height? And it's this line here. That is called the apothem. So sometimes you have to use the apothem to do a right triangle on the inside of this shape. And then last, this one we don't use nearly as much, but you see how the height is connected to the corner? This is the radius of the base, and it connects the height to the corner, which is then attached to the lateral edge. So there's a right triangle here that is height, radius, lateral edge. So to recap, we have slant height, base edge, lateral edge we're going to have to use. We have height, apothem, lateral edge over here. Where the where the slant height, where the slant height's the hypotenuse, and then we have height, radius, lateral edge, where the lateral edge is the hypotenuse. So we have 3 more right triangles to consider. These are not easy to see. I'll try to kind of draw them here, but we have height is connected to the lateral edge via the apothem. So we have a right triangle that is the height, the slant height, and it's connected by the apothem. And by the way, slant height is often this cursive L. Don't ask me why, I don't know. It might just be a little lowercase l, but it is an L for, I don't know. S is already taken, so they use L. Don't know, but it's slant height L. There's another one in here that connects the height to the corner, and that is the height connected to the corner via the radius, and that is the lateral edge as the hypotenuse. And then the next one, we probably use it the most often, is the slant height is connected to the lateral edge. So we have another right triangle that the slant height is connected to the lateral edge, and it's 1/2 the base edge. This would be half of a base edge here. And the lateral edge is the hypotenuse. I hope you watched that. I hope you understood that. You can rewatch it. You need to know these 3 right triangles. And just so we're clear, we still have this one on the actual base where you have the apothem, the side, and the radius. That's the one we did last week. There are 4 right triangles to consider. All right, so we're going to draw a net of a pyramid and derive the area formula. So here we go. So if we have a pyramid, we'll do this pyramid right here. So draw a net of the pyramid. We're going to have this square, and I already kind of did this, but we would have 4 connected triangles basically. And on the actual shape, they could be connected to the square something like this. That's what it would look like if you laid it flat. So what we're going to do is if we just get the perimeter of the base, if we get the perimeter of the base, that is these 4 lines. That would be the perimeter of the base. That is like the base of all triangles combined at the same time. And then this number here, that's the slant height. This number is the slant height. So, like, remember one triangle is 1/2 base times height? Well, to do all triangles at the same time, the lateral surface, that's all the triangles, it'd be 1/2 times the perimeter of the base times the slant height. And that would get all of them at the same time. And then what do we do to get the total surface area? We add the base. So it's the lateral surface area plus 1 base. There are 4 triangles and 1 base on this pyramid. These are all lateral surfaces. The base is not a lateral surface. And then the cone is kind of the similar idea. You have pi RL. Remember that the perimeter of the cone is called circumference, and it's 2 pi r. So think of it if you did 1/2 times 2 pi r. Well, wouldn't the 1/2 cancel out the 2, leaving you with pi r, and then it's times the slant height. So it's actually the exact same formula. And then you add 1 circle, which would be just 1 pi r squared. You have 1 circle. And just so you know, a cone, it has a circular base. It's really hard to picture. You can Google it. Actually, let's just Google it right now. It's the net of a cone looks a little funky. Net of a cone. They're going to draw it better than me. So it won't look like what you think it will. Well, at least maybe not. But it looks something like this. It's a circle and then a part of a circle. It's a circle and a part of a circle. This piece of pizza, it looks like a piece of pizza. It would wrap around the circle, the circular base. All right. So those are the formulas. Let's do a problem. If the following prism has a slant height, we got to remember where that is. The slant height is down the middle of the side of 15 and lateral edges of length 25. This would be from the apex to the corner. That's 25. Find the surface area. Surface area is 1/2 PL plus B. So again, we need the perimeter of the base and the area of the base, right? So if I draw just the base, we actually don't know any measurements on the base, okay? We don't know any measurements on that base. So we need to use our right triangles that we talked about earlier. If we connect this, we have a right triangle here where 15 is the slant height, 25 is the lateral edge, and we can do Pythagorean theorem to get the missing side. So this would become, I would reduce, divide by 5. This would be a 3, 4, 5 triangle, which means that's 20. That means this length is 20. So what does that mean on my square? The entire side would be 40. So the perimeter and area of the base, well, the area of the base would be 1600 and the perimeter would be 160, right? Because the area of this would be 40 times 40 and the perimeter would be 40 times 4. Those are very different numbers. And then the slant height, we know they gave it to us, that's the 15. So the actual answer here is going to be 1/2 times the perimeter of the base, 160, times the slant height, which is 15, plus 1 base at 1600. So this would be 80 times 15. That would be 800 plus 400. That would be 1200 plus 1600 would be 2800. So that would be the surface area. If they ask you for the lateral area would just be 1200. They didn't say find the lateral area, but if they did, it would just be the 1/2 PL. This is the lateral portion of the formula. And then what are the formulas for a cylinder and cone? I've already talked about both of those. So let's see. Oh, they didn't give us an example problem. But if you notice real quick on a cone, it does have a single right triangle. The cool thing about a cone is it's the same right triangle everywhere. So let's actually do a cone problem real quick just so you can see it. If I have a cone and they tell you like the radius is 10 and the slant height is 15. So if I were to draw the cone, which I'm not good at doing, The radius would be 10. The slant height is 15. We have a right triangle here. Actually, that's all we need. Oh, I'm going to change it. Let's not get the slant height. Let's say that the height is 15. Height is 15. Let's make it slightly different. That's this number. So if I wanted the total surface area, that would be pi RL plus pi R squared. We would have to get L. This is the slant height. It's the same in every direction. The cone doesn't have a different slant height for different directions. So we work on that right triangle. I would reduce by 5. This would be 2 and 3. So that would be the square root of 9 plus 4. That's the square root of 13. Times 5 would be 5 root 13. So I have the slant height now. So the surface area would be pi times R times L, which is 5 root 13, plus pi times R squared. That would be the total surface area. So this would be 50 pi root 13 plus 100 pi. Those are unlike terms. You would have to leave it like that. One of them is pi root 13 and one of them is pi. You can't do anything with that. So that's what a cone would look like. So it's your job to work on the worksheet today. You're going to have to be able to use these formulas. Good luck. Have fun.